Hello and welcome to another video. In this video we're going to be working on the second problem of this week's Biweekly Contest, and it's going to be maximize area of a square hole in a grid. And to be honest, in this problem there's like a ton of information they give you, and the hard part about it is just figuring out like, okay, they give me all these things, how do I actually simplify it down? So let's try to do that. So there's a grid with n plus 2 horizontal bars and n plus 2 vertical bars, initially containing 1 by 1 unit cells. The bars are 1 indexed. You're given two integers n and m. You're also given h bars and v bars. H bars consists horizontal bars in a range. V bars consist horizontal or vertical bars in a range. You are allowed to remove bars that satisfy any of the following conditions. If it's a horizontal bar, it corresponds to a value in h bars. If it's a vertical bar, it corresponds to a value in v bars. Return an integer denoting the maximum area of a square-shaped hole in the grid after removing some bars. So if we take a look at some of these examples. So remember, n is the number of horizontal bars, but the actual bars is n plus 2. So we have 1, 2, 3, 4 bars. And m is the number of vertical bars, but the actual number of bars is m plus 1, so 1, 2, 3. And they are 1 indexed. H bars are the bars we are allowed to remove. So we can remove this bar, we can remove this bar, and we can remove this bar. And they're basically saying, like, what's the most we can remove to make a square? So we would want to remove... Actually, in reality, you would want to remove every bar, but it's hard to figure out, like, how to make a square, right? Because you would want to remove every bar, so you would actually want to make it look like this, but what's the biggest square you can actually make? Well, the biggest square you can actually make is just this. After we can remove, like, every single bar. Or we can keep this bar and make the same square, right? So we'd remove this bar and we'd remove this bar. So let's go to the next example. So here we have only one bar in each direction, so we'd want to just remove both of them, and then we'd have the square, and the area would be 4. And in this previous one, the area was 4 as well, right? So just because you can remove a bunch of bars, your square is still limited to the minimum of your height and your width, right? Like, for example, if I have a height of 8 and I have a width of 6, to make a square, I'd have to pick the smaller dimension and use that, right? So this is kind of what it is here, is even though we can remove every bar, we can't make a 3 by, this is a 2 by 3 square. We can't make a 2 by 3 square. We'd have to make a 2 by 2 square. Okay. And in the last one, once again, we are allowed to remove every single bar. The horizontal bars are this bar, vertical bars are this one. So it's basically the same kind of thing, like what's the biggest square I can make when removing all of these bars. So I can remove everything, but still, even if I removed every bar, I can't make a 1, 2, 3, 4 by 3 square, right? You can't make a 4 by 3, so let's make a 3 by 3 square, and so we'll get 9 here. So essentially, we need to figure out how to do this, and if we go back up to the constraints, n is 10 to the 9, then m is 10 to the 9, so we can't just like remove, or we can't just iterate through the entire grid because it's way too big. So you would need to have like a log n solution, but it's way too big. So they kind of give you a hint here that instead of iterating through the grid, you want to iterate through bars you can actually remove. And so let's actually draw this and kind of understand what we want to be doing. And it's going to be pretty straightforward once we actually draw it. So let's actually draw a 10 by 10 maybe. Yeah, I think that'll be pretty good. So let's draw a 10 by 10. As usual, my drawings are going to be really bad, so let's see what happens. So be like this. And let me actually do this. So 2, 3, 4, 5, 6, 7, 8. So 1, 2, 3, 4, 5, 6, 7, 8. One more, right? So like this. That's 10 bars there. Now we need 10 bars in the other direction. So we actually need 8 total. 2, 3, 4. Actually, I think we need 9. 5, 6, 7. So that's 1, 2, 3, 4, 5, 6, 7, 8. One more. So it's not super well spaced out, but this is going to be fine. And now we will number it as well. So let's say this is numbered, so numbered 1, 2, 3, 4, 5, 6, 7, 11. It's fine. And then we have 2, 3, 4, 5, 6, 7, 8. Looks like I have too many in here, so I'll actually get rid of this last one, I guess. I can do that. There we go. So now we have 10 total. Okay, or at least 10 distance. 3, 4, 5, 6, 7, 8 bars. 1, 2, 3, 4, 5, 6. So let's just leave it like this. And now what we're going to do is we're going to represent the bars we can remove in blue. So let's say we can remove this bar down here. Let's say we can also remove this bar up here maybe. And let's say we can remove this bar, and finally let's remove some vertical bars. So let's say we can remove this bar, and we can also remove this bar, and this one. Okay, so now we have this kind of bad drawing, but essentially blue bars are the ones we are allowed to remove, and the green ones are the ones that we are not. So how could we do this? Well, it's actually pretty straightforward if you think about it. What you need to do is you need to figure out how many consecutive bars can I remove. For example, let's say I want to remove this bar, this vertical bar on the very right. Well, if I do that, let's see how much my area increases, right? Like if I just get rid of this, then I can only have a width of 2, right? So if I remove, let's say I remove this bar, and I also remove this bar, these don't really have anything to do with each other because your square won't be in the same location, right? You're going to have a square here and a square here. So if you remove bars that aren't next to each other, that doesn't really help you because you can only build one square. So really what you're looking for is how many bars can I remove that are right next to each other? And so in this example, let's say we're removing vertical bars. Also notice that if we remove a bar, like let's say we remove this bar, this will help the this will help a dimension all the way down, right? So if we get rid of this, this helps our width for every single square now, right? For every single square all the way down. So that's another thing to notice. So essentially, like I said, you don't, once your bars aren't right next to each other, it doesn't really help removing them. Same thing here. Like if I remove this bar and this bar, because they're not right next to each other, I can't draw one square. So it didn't really, like, each bar made the square bigger, but it made two different squares bigger, right? This bar made this square bigger, this bar made this square bigger. So what we're really looking for is how many bars can we remove, like I said, right next to each other. So let's kind of walk through this, and we're going to get our dimensions. So when we remove vertical bars, we will increase the width of the square. So let's just say the width and the height right now are 1 by 1, because obviously even if you can't remove anything, you're going to be able to make a 1 by 1 square. So let's say that as our default. Now we basically have to go through our available bars to remove. So let's start with the vertical ones. So we can remove vertical bars, and we're basically going to check, like, what's the biggest continuous number of bars that we can remove. So to figure out what's the most continuous bars we can remove, we're going to actually traverse the bars, not the grid, because remember the grid is way too big, but the bars is only like 100. So we're going to start at 3. We're going to just start at the first index in the bars, and we're going to say, okay, we'll keep some like pointer as where we started, and then while the next bar is only 1 greater, let's just keep traversing. So we'll go to 4, we'll go to 5, and the next bar is 7, so we'll stop at 5. Then we figure out like how far did we traverse, so we went from 3 to 5. So we went a total of 2. And now what if we remove all of these bars, what would the width of the square be with this that we removed? So the square is actually going to be 2 plus the distance that we traveled, right? And you're going to see why here. So in our case, the distance is 2, right? We went from 3 to 5. So the width should be 4. So let's see what happens if we remove these bars. So we remove this bar, and this bar, and now you can see the width of the square is 4. So you just take the distance that you traveled and you add 2, and then you check what's the old width. So the old width is 1, but now we actually got a distance of 4. So we'll update our width to be 4. So you're just traversing the bars, and any continuous chunks, you're figuring out how far did I traverse in this chunk, and then anytime you go to a new number, you would just start over and you'd see how far can I traverse in this chunk. So now that we are done traversing here, we're going to go to the next number. So we were at 5, now we're going to go to 7, and we're going to do the same thing. How far can I travel? Well, for 7, there's nowhere to travel, so the distance is going to be 0, right? So if it's 0, then it's the same thing. 2 plus distance is your width, so just 2 plus 0, so it's going to be 2. And notice if we remove the 7, our distance for this square, if we remove this bar, will be 2. So that's kind of the idea. You basically traverse through your width and your height, or your bars, and you just check, like, what's the biggest continuous chunk I can remove, and then you can figure out how big your square will be based on that distance. And you have to look for continuous chunks because, like I said, if they're not continuous, like if I just remove the 3 and the 5, I can't make a square including both these 2 bars that I removed because there's still a separator here, right? So in order to make a square, you have to remove bars that are 1 by 1 by 1 by 1. And if there's ever a horizontal bar you can't, then you have to start over. So now that we got our width, let's look at our height. So same kind of thing. We're gonna have an initial height. So our height here, we're gonna go through our horizontal bars now. So our first bar is 4, and we're gonna see how far can we travel. So we can go 4, 5, 6. This is as far as we can travel. How far did we travel? We traveled 2, and it's gonna be the same formula. It's gonna be 2 plus however far we traveled. So we get 4 here, and let's see what happens if we remove these bars. So if we remove these bars, our height of the square will be 4, right? So that is why it's 4. So then we check what's our old height. Our old height is 1. We'll update it to 4. And then now that we went through all of these, our last current index was over here. Now we go to 9 and we say, okay, well, for 9, we can't travel anywhere. There's only 1 bar we can remove here. So this is just going to be a square of height 2. And we just check, is height 2 better than what we had? No, it's not. So the biggest square we can make is 4 by 4 by removing this section and this section here. So let's see what happens. If we remove this section and we remove this section, now you can see this is this square here, right? So by drawing out the matrix, it's pretty straightforward. As you can see, it's of width 4 and height 4. And that's pretty much how you do it. So they do give you like a lot of unnecessary information, and you have to realize, okay, how do I make a square? What do I actually need to do? And I need to traverse the bars instead of this end because this end's way too big, while this is only 100. One last thing here they don't really tell you is or they do kind of tell you, but the bars aren't necessarily sorted. So you do have to sort the bars just to make sure that they're actually increasing. Because in some of the test cases, your bars won't be sorted. But because the bars are only 100, it's totally fine. They'll still run super fast. So that's pretty much it. We just run through the bars and we check for what's the biggest continuous sequences, and then we could figure out like what our height and width would be from that. And so now we have enough to code it up. So we're going to sort the bars. So we're going to say hbars dot sort vbars dot sort, and we're going to make a helper function because getting this continuous thing in the bars is going to be basically all the exact same code for both of these. So we're just going to make a helper function called def get dimension, and it's just going to take an array of bars. And essentially what we have to do is our index will be 0. Our result will start out as 1, right? Our initial dimension will just be 1. We can always have 1. And we'll say, while index is less than length of the bars, we are going to keep track of where we started, right? Like where we started, and see how far we can go. So we're going to say left equals I, and then while I plus 1 is less than length bars. So if we can go to the next one, and bars of I plus 1 is just, remember, we have to go to the next number over. So if we started at 2, we have to go to 3, 4, 5. So there has to be like the next number available. So if the next number available is there and it's equal to the current number plus 1, then we can go to the next number. So we could say go to the next number. And finally, once we're done with this loop, now we have to figure out like how far did we travel and maximize our result. So result is gonna be the maximum of the old result. And it's gonna be I is where we're currently at, left is where we started, and then plus 2 like I showed when we get rid of these. So it's gonna be the distance traveled, which is this, plus 2, and that's gonna be your dimension. Then we need to go to the next available thing in the bars, right? So we basically stopped where we couldn't go to the next available one that wasn't consecutive or contiguous. Now we have to go to the actual next one in the bars. So we'll say I plus equals 1 here, and we'll do this again. And then finally, we need to say return result. So we can do this to get both dimensions. And now all we have to do is call this on both of the bars. So we'll say side equals minimum. So remember also, I think I mentioned this, once we get our 2 dimensions for our height and our width, like let's say our height is 5 and our width is 7, to make a square, the dimensions have to be equal. So if they're not the same, then your dimension for the side is the minimum of these two. So if you have like length 7 and width 5, then you have to say, okay, I have to go with a 5 by 5. I can't go any bigger than that because I'm limited by the other one. So it's going to be min of get dimension for h bars. So that'll give us 1 dimension. And then get dimension v bars will give us the other dimension. We'll say, let's take the minimum one of that, because if we have a 7 by 5, we can't make a 7 by 5 square. It would be 5 by 5. And then now that we have our side dimension, now we can just return side squared, or side times side or something, same thing. And that's pretty much it. So let's try to run it. Probably misspelled it, very likely. Okay. And let's submit. And let's take a look. So I think when I was running it, it either beat like 75 or 100. There's not too many in here. So there's probably like, I don't know how many submissions, not a lot. Yeah, so let's go through the time and space for this one. And it should be pretty fast, and you can see it's only 57 ms because we are just going through the bars. We're not going through, we're completely ignoring N and M, and like we're not even using it at all. So for the time, it's going to be, so we need to sort each one of these. So let's say H is the length of H bars and V is the length of V bars. So it's going to be like H log H plus V log V. Because we're sorting them and then we're just basically going through them one index at a time, right? So this get dimension is going to take the length of the bars time, and we have to do that for each of them. So it's going to be, the sorting is going to be the main thing that takes the longest. And yeah, you do have to sort them because sometimes they'll give you bars in different orders, and you have to make sure you're actually going through the side in order. And for the space, it should just be of 1 because we don't have any other variables. We just have the current index where we're at and how far we traveled for each chunk. And yeah, I do think this problem is kind of tricky because they just give you so much stuff, and it's kind of hard to figure out like, okay, what do I need to throw out of here? What is actually going on here? So, but the actual, like, once you figure out how your squares work and you realize, okay, I have to get rid of lines that are consecutive. If I get rid of one line here and one line all the way down here, then this isn't in the same square. So I have to get rid of lines that make up the same square. It's pretty straightforward. So hopefully you enjoyed this one, and if you did, please like the video and subscribe to the channel, and I'll see you in the next one. Thanks for watching.